Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this lecture, we are going to see about bias compensation. So, biasing is actually the method of giving proper supply voltage to a device to operate in the stable Q point. So, the biasing techniques offer stability to the operating point by selecting proper ICQ and VCEQ values. But but the method of biasing also reduces the gain of the circuit. In applications where the reduction in gain is not acceptable, we need to impose compensation techniques. Bias compensation techniques make use of temperature sensitive devices such as diodes, thermistors, transistors, sensistors, etc. So there are several commonly used compensation techniques such as diode compensation for base emitter voltage, diode compensation for leakage current IC node, and thermistor compensation. Now let's see it one by one. So the first method of compensation we are going to see about is diode compensation for base emitter voltage. So just look at this figure. So in this figure we are keeping a diode at the emitter terminal and which is connected in series with a resistance Re and which is provided with forward supply voltage of VDD. And so when we are applying, just consider the figure at the bottom. So when we are applying Kirchhoff's voltage law to the base emitter loop, we are having the equation as VBB minus IBRB minus between base and emitter terminal, we are having the built-in voltage VBE. So minus VBE minus IERE plus the diode voltage VD is equal to 0. And we know that I is equal to beta plus 1 into IB. So when we are substituting this value in the above equation, we get IB equation as IB is equal to VBB minus VBE minus VD dividing by RB plus beta plus 1 into RE. So in this equation, we come to know that whenever the VBE voltage varies or increases, its effect will be decreased with the help of the diode voltage VD. So as a result, we will have a constant current. So if we observe the above equation carefully, we see that the change in the base emitter voltage of the transistor due to the change in temperature is nullified because the effect of increase in VBE will be cancelled by the subtraction voltage VD. So next we are going to see about diode compensation for leakage current IC naught. So look at the figure. So here the diode is connected between the base and emitter of the transistors, and here the diode is reverse biased. Actually, the negative or the cathode of the diode is connected with the positive voltage VBE and the positive of the diode is connected with the negative voltage of VBE. So the base current IB is equal to I minus ID. Okay. So therefore the collector current IC is given by, this is a standard equation of collector current, which is beta into IB plus beta plus 1 into IC naught. So instead of IB we are putting the equation 1 here, and as beta and beta plus 1 are nearly equal because the value of beta will be around 50 and maybe in some cases it will be 100. So when compared this value with 1, beta value will be very high. So that we can approximately consider beta and beta plus 1 as equal. So that the above equation of IC can be rewritten as IC is equal to beta I minus beta ID plus 1 plus beta is equivalently written as beta. So it is beta IC naught. So rearranging these equations, we get, if we are taking beta as common in the second and third terms, then IC is equal to beta I minus beta into ID minus IC naught. And the last method of compensation is thermistor compensation. So in this method, a thermistor is connected from the base to the ground of the transistor. And the thermistor used here is a negative temperature coefficient of resistance, which means that whenever temperature increases, the resistance of thermistor will decrease. So just consider the case when the temperature increases, the value of RT decreases. So when RT decreases, which reduces the voltage VBE. So when VBE decreases, this will in turn decrease the base and collector currents IB and IC. So when IC increases, automatically the rise in IC will be decreased. And the same phenomena will happen when the temperature decreases. So just consider the case when temperature decreases, the thermal resistance RT increases, and when it is increasing, correspondingly the voltage VBE and IBIC also increases, so that the decrease in temperature effect will be cancelled out by the thermistor. So these are the compensation techniques used in transistor. Thank you.